Chapter 8.3. Today we're going to get a look at graphing the quadratic function ax squared plus bx plus c. Now if you remember from the beginning here, this is the standard form of a quadratic. We've already looked at what a and c do. Today we're going to get a look at what this linear term bx does to the graph of our quadratic function. So let's jump in here. The graph of a quadratic function, ax squared plus bx plus c, is a parabola with some of the following properties. If a is greater than 0, in other words, if a is positive, our parabola is going to open up. If a is less than 0, our parabola is going to open down. Our y-intercept now is going to be found at the point 0 over c. So take a look. Whatever c value is going to be our y-intercept. The axis of symmetry now is going to be different. It's no longer going to be our y-axis. It can be found using the terms of our quadratic. We're going to take the opposite of the b value and divide it by 2a. And then we're going to use that opposite of b over 2a as the x-coordinate of our vertex, right? Because all axes of symmetry pass through our vertex. Now we're going to use this x-coordinate and we are going to evaluate f of the opposite of b over 2a, and that's going to give us our y-coordinate of our vertex. So more on that here in just a second. Let's take a look at example 1. Now we're given the quadratic form 2x squared minus 4x plus 5. Our a value is 2, our b value is negative 4, our c value is positive 5. And we're asked to find the axis of symmetry, which remember said to take the opposite of b and divide it by 2a. Well, the opposite of negative 4 is positive 4, and that positive 4 is going to be divided by 2 times our a value, which is 2, so that's 4 over 4, which is 1. So our axis of symmetry is the vertical line x equals 1. Now, in order to find the vertex, we got to find both the x and the y coordinate. Well, remember, our x coordinate comes right from over here, our axis of symmetry, and in order to find our y coordinate, we're going to evaluate our function for that value of x, which is 1. So let's substitute 1 in. Now we have 2 times 1 squared minus 4 times 1 plus 5. Be careful to follow your order of operations. We're going to square first. 1 squared is 1, and then 1 times 2 is simply 2, minus 4 times 1. Now 4 times 1 is just 4, so it's minus 4, and then plus 5. Adding and subtracting left to right then is going to be 2 minus 4. That results in negative 2, and then negative 2 plus 5 is positive 3. So that's our y-coordinate, and that makes our vertex coordinate 1, 3. Remember, the 1 comes from my axis of symmetry. The 3 came from evaluating the function for that x value. All right, example 2. Getting into some tricky business. Again, we're going to try to do everything here without a graphing calculator. We want you to know all of the properties of a quadratic and be able to determine what its graph looks like just by looking at the equation. So graph the quadratic function by finding the key properties below. Let's start off by finding its axis of symmetry. X equals the opposite of b, which is negative 2, all over 2 times my a value, which is just 1. All right, that's going to give me 2 over 2. And again, that's 1. So my axis of symmetry is this vertical line straight through x equals 1. All right, now I'm going to find my vertex. I know that my x is equal to 1, so I'm going to evaluate my function for that. That gives me 1 squared minus 2 times 1 minus 3. So 1 squared is 1, minus 2 minus 3, that's going to result in negative 4. So the vertex is 1 over and 4 down. I can now plot that point on my axis of symmetry. I know that my a value here is equal to 1. That tells me that my parabola opens up. That also tells me how much of a vertical stretch or shrink from my parent function this graph is. And since a is 1, I know that I can move to the right 1 and up 1 to plot a point, I can move to the right 2 from my vertex and up 4 to plot a point. Now this is reflection symmetric over that axis of symmetry, so I got those 2 points that I can graph as well. And now I have enough for a parabola. If not, you should always take a look at your y-intercept. Remember that y-intercept is 0 and then whatever your c value is. Well, 0, -3 is my y-intercept, and you can see that I've already found that point. So let's graph this parabola here as best we can, and there you go. All right, moving on to the back page of our notes for today. The y-coordinate of the vertex of the graph, ax squared plus bx plus c, is the maximum value when our function opens down, and it's the minimum value when our function opens up. And you can see that here by these 2 illustrations. Parabolas that open down have a maximum point, kind of like the top of a roller coaster, and parabolas that open up have a minimum point, kind of like the bottom of a bowl or a dish. All right, tell whether the following has a maximum value or a minimum value. Then find that value. All right, so if I look here, I'm going to first of all start off by looking at my a value. My a is greater than 0 here, so I know this is going to open up, which means it has a minimum value. All right, next I need to find my y-coordinate. Well, I'm just going to find my vertex like I've done in previous problems by starting off by finding my axis of symmetry. So I have the opposite of b over 2a, and that's going to give me -1.5. Now, in order to find my y-coordinate, I'm going to evaluate my function for -1.5. So I'm going to say f of -1.5 is equal to 5 times -1.5 squared plus 15, whoops, forgot that one, times -1.5 minus 10 more. All right, pause the video here, crunch those numbers out with your calculator, and tell us what you get for your y-coordinate. Your vertex then should be -1.5, and then whatever you crunched out there in that problem. All right, let's try example B. Example B, I see that my a value here is less than 0. It's negative, in other words, and when it's negative, I know that my parabola opens down, and I'm going to have a maximum point. All right. After I've noted that, I'm going to go through the steps here of finding my vertex. My x value is, my axis of symmetry should be the opposite of b over 2a. That's -2 over -2, and that's going to give me an x value of 1. Next up, I need to evaluate my function for 1. So I have -1 squared plus 2 times 1, and then plus 6. So be careful here. This first term is really not -1 squared. It's the opposite of 1 squared, which is -1 plus 2 more plus 6. When I add all those together, I'm going to come up with 7, and my vertex point here would be 1, 7, and this we would say is our maximum point. All right, well, we are going to pull out the graphing calculators here for this next one, so get that graphing calculator handy. What it says here, we have the tallest hill of a roller coaster track forms a parabola, and it can be modeled by this function. All right, where x and y are measured in feet, I want you to estimate and interpret the maximum value of that function. So let's go to our graphing calculators, and we will type into y equals our function here. All right, go ahead and make sure you have everything entered in correctly. And then we will try to find the graph of that. All right, once that's entered in, we're going to now go to our graph, and most likely we're not going to see it It's going to be way outside of our window here. We just see just a little glimpse of it. So let's go to our window and let's change our x max to be 100. That should get it, we think. And we'll say our x scale will go up by tens. And then let's get our y max. And we'll make our y max, how about we'll go up to 1,000. We're hoping that gets it too. And our y scale will go up by hundreds. All right, let's see if we got a graph now in there. Oh, perfect. Okay, so there's our parabolic track, and we wanted to calculate the maximum. On your graphing calculator, you can do that by pressing second function trace. That's the calculate menu. Now you can see where it says maximum is number 4. So scroll down to number 4, press enter. Your calculator is going to prompt you for 3 things. It's going to ask you for the left bound. So you're going to need to move your cursor to the left of that maximum point and press enter. Then it's going to ask you for a right bound. So move your cursor to the right of that maximum point and press enter. And then finally to guess, so just put it somewhere close and press enter. Here you can see that the maximum looks like it's about 24.5 and then 298. So 24.5, 298 is our maximum point. All right, we'll just round that to the nearest whole foot. So we want to interpret the maximum value here. So the maximum is that 298, and we would say to interpret that the height, the maximum height of the roller coaster, and we'll just shorten that to RC, is 298 feet. All right, our last problem for today.